Thank you, Alex, for the introduction. Good morning to you, everyone. Welcome to, after so many years of not being able to see each other in person, we are finally doing this. We can talk to each other in person. It's great. Thank you, JSHeroes, for the invitation, and thank you for organizing this event and to make this happen. So today we're going to analyze the evolution of scalable CSS, which covers a period of about 20 years. So as I have only 30 minutes at my disposal, of course I won't be able to cover everything in detail. But let's see how it goes. So the main reason for this talk is that today's ecosystem of CSS tooling is like really complex and difficult to figure out. And in order to fully understand the current state of the ecosystem, we need to basically know how we got here in the first place. So as Carl Sagan said, we have to understand the present. In order to understand the present, we must know the past. That's why you can view this talk as a well-researched chronicle describing how CSS tools, techniques, and paradigms have evolved over time during the past 2 decades. What is a chronicle? Well, it's a recording of significant historical events in the order of their occurrence as seen from the chronicler's perspective. Who is the chronicler? I'm glad you asked. My name is Andrei Pfeiffer. My name is spelled exactly like Michelle Pfeiffer. I was born and I live in, it's a fact. I was born and I live in Timișoara in the west part of Romania. And I'm currently working as a co-designer for Smile Cloud Biometrics, a local product company in Timișoara focused on cutting-edge dental software solutions. I'm also deeply involved in the JavaScript community. As Alex mentioned, I organize Team.js, which is the local JavaScript meetup in Timișoara, and also Revo.js Conference, an annual event actually highly inspired by JSHeroes. Last but not least, I dedicate a lot of my time to writing technical content on my personal blog, which you can find at andreipfeiffer.dev. So, not back, but forward. Clickers are difficult. Bear with me a second. Okay, so today we're not gonna focus on any type of CSS, right? Instead, we will focus on the so-called scalable CSS. So to keep it short and simple, whenever I think about scalability, I ask myself one simple question. If we greatly increase the size of the code, does the effort to maintain it increases proportionally? If the answer is yes, then we have a potential scalability concern. Ideally, we would like to maintain a constant effort when maintaining code, regardless of its size. That's the ideal, right? Now, CSS wasn't initially built for highly dynamic and large-scale applications. It was initially built for static web documents. Therefore, it has some inherent issues in regard to scalability. If I would have to name only 3 of them, I would mention naming collisions and unexpected overrides, because all the styles end up in the same one single global namespace. In order to fix these issues, we would probably rely on specificity, which will only lead to the specificity words. And if you haven't encountered this problem, please talk to me in the break, because I'm really interested in how you avoided them. And last but not least, to remove unused code, also known as the zombie code, is non-trivial, especially in highly dynamic applications with plain CSS. And this is not new. Like this is clearly stated back in 2005 by Simon Williamson on his blog, when he stated that it's time to talk about the elephant in the corner of the room, style sheet maintainability. And keep in mind, this was in 2005. Like CSS wasn't even widely used at that point. Therefore, around the same period, in 2005, the first good practices started to surface under various blog posts. There are so many of them, we won't cover them in detail, but there are a few of them that still apply even today. For instance, avoiding ID selectors in CSS definitions and prefer classes instead, as they are more flexible. Or trying to keep the specificity as low as possible and avoid overly specific and superfluous selectors. Okay, these are good practices, we can apply them, but at the end of the day, they don't really scale. We as a community of developers came to the conclusion that they don't really scale. And this happens for a bunch of reasons. First, there is no official comprehensive guide with all the practices that we should learn and apply and apply on our projects. They are spread around in blog posts and articles and books and conference talks. They are also cumbersome to learn and to teach. Not to mention that we as developers are very opinionated, right? And we rarely reach a consensus regarding which set of practices should we apply on our projects. But probably the most important or the biggest problem is that the effort in maintaining and apply these practices on a large code base scale and increase proportionally with the size of the code. So we have a scalability concern. Therefore, we needed some way to automate this manual process of maintaining style sheets. We needed some tools, and the first generation of tools were the CSS processors. Some of the popular ones, probably you know, it's Sass, Less, Stylus, and Post CSS. Now they introduced so many useful features, but I would like to talk about two of them in particular. One of them that all CSS processors support are variables, right? You can define one single source of truth for a single value in CSS and reuse it multiple times whenever needed. And we have to change it in one place, and the changes will reflect everywhere else. Now, this feature alone became so popular and so used and so useful that several years later, it was turned into a standard syntax under the name of CSS custom properties. So CSS processors, community tools, influence the web standards greatly. But another one that truly changed the way we author CSS styles nowadays is a combo of two features, nesting and the parent selector, because they provide what I like to call contextual styles. And these contextual styles basically allow us to define a selector only once and collocate inside it any pseudo-classes and selectors. With plain CSS, we would have to duplicate the selector, right, to introduce a lot of duplication. Now with complex selectors, this becomes a scalability concern. And if we throw media queries into the mix, then the problems scale exponentially. This again was so useful that 15 years later, we have a first public working draft of this feature. Basically, it will be introduced at some point as a standard syntax under the name of CSS nesting module. Now, going back to practices, they are not easy to adopt, easy to figure out, like what set of practices should we apply. That's where CSS methodologies enter the scene, as they provide a strict and a concise set of rules that are easier to adopt and to apply. In 2008, object-oriented CSS was coined, although it became popular only 2 years later. In 2010, block element modifier was open source, although it was introduced and used internally many years later. The next year, in 2011, we have SMAX, also known as, which stands for Scalable and Modular Architecture for CSS. And a few years later, we have IT CSS, the inverted triangle CSS. Now, we're not going to dive deep into the details of these methodologies. There are some interesting differences between the first two and the last two. So if we were to look at a forest full of trees, the first two methodologies focused on the individual trees of the forest, like individual components. They taught us how to identify reusable visual patterns on a page and implement them, define them, and reuse and customize them throughout our pages and applications. The other two, SMAX and ITCSS, focused on the forest as a whole, right, on the high-level architecture of our applications, teaching us how to structure our styles on different levels. Now, during that time, the HTML Living Standard encouraged us to use values that describe the nature of the content rather than values that describe the desired presentation. To put this in other words, we were encouraged to use the so-called semantic CSS, or use semantic names which convey meaning, like main menu and product item, instead of non-semantic names, which convey their implementation. Clickers are crazy. Instead of non-semantic names that convey implementation, like background dark or align center. Now, at that moment, this was a de facto standard, like all of us would probably use this mindset, this approach, the semantic CSS. But it has some notable limitations. One of them is that we will use a lot of repetition in the CSS code. We will probably define many times display flex, font weight bold, position relative, and many others. Due to this duplication, our style sheets will keep growing indefinitely, right? And anytime we need to override some styles or we need to implement a new component, we will add more and more classes to our style sheets or definitions. And last but not least, and again, most importantly, semantic CSS relies on semantic names, on meaningful names. And we all know that naming is truly difficult, especially since we have still the same single global namespace of CSS. So we haven't basically solved the fundamental problems of CSS by now. At some point, it became clear that we needed some way to restrict the effect of styles to leak outside a specific component, to encapsulate them, right, to scope them to a specific component. The problem was so crucial that in 2011, even the standard committee joined this battle against the global namespace, and they introduced the scoped CSS, which is basically a new attribute on the style tag, which prevents styles from leaking outside a certain element in HTML. Now, this standard was abandoned, and it was removed from the spec a few years later, so we didn't get to use it that much. Well, standardization is a very lengthy process. It takes years for a feature to get to the candidate recommendation stage and basically be implemented in most browsers. Therefore, the community couldn't just sit and wait for a standard solution to become available. So what do? They build their own tools. Like in 2015, a few very smart people built CSS modules which basically provide styles encapsulation through tooling instead of relying on a standard API. And as a side note, CSS module started initially as a post-CSS plugin. So another proof that CSS processors played a huge and crucial role in the evolution of scalable CSS. Next year, Shadow DOM was introduced, this time a successful attempt to introduce styles encapsulation through a standard API at the platform level. And as Eric Bidelman said back then, Shadow DOM fixes CSS and DOM. It introduces scoped styles to the web platform without tools and naming conventions. And to be fair, if Shadow DOM fixes CSS, you know how it was before that, right? It was broken. And styles encapsulation represent a cornerstone in the evolution of CSS because they represent basically the end of global CSS. We could finally scope our styles to a specific component, to the component they belong to in the first place, and not have to worry about naming collisions within a global namespace. It was so useful and so elegant that it became an industry de facto standard quite soon, being implemented in most, if not all, JavaScript frameworks that exist today. Now, everything that we talked about so far, practices, CSS processors, CSS methodologies, and styles encapsulation, we can put them under the same umbrella of semantic CSS, which is the traditional paradigm to CSS styling. But it's not the only one. There is another one that basically tries to solve the same problems, but taking a very different approach. This paradigm is called atomic CSS. It was coined in 2013, and it contradicts all the fundamental principles of semantic CSS. There are a handful of frameworks that popularize this atomic mindset: Bus CSS, Tachyons, Atomized CSS, and Tailwind, which is very popular nowadays, we won't go into the details of these frameworks as their APIs differ quite a bit. Instead, we look at the fundamental principles of atomic CSS. So as I said, atomic CSS totally contradicts what semantic CSS encourages us to do. Atomic CSS uses non-semantic names, which fully describe their implementation, like text red, for instance, instead of using semantic names that describe the usage and their purpose, like text error. Now, the main reason for this is that semantic classes typically, usually contain multiple CSS rules. Now, the more rules a selector contains, the less reusable it becomes. Therefore, to benefit of the highest amount of reusability, atomic CSS uses only single rule class definitions, which is really mind-blowing. But, I mean, using such classes is not very, very novel. We would probably use a bunch of these classes even before we know about atomic CSS. Also, most semantic CSS frameworks expose a lot of such utility classes for text color and background color, for typography, alignment, and for spacing, like padding and margin. The only difference is that atomic CSS takes this to the extreme, and using exclusively only this type of single rule classes, which we can mix and combine and but in any way we like. But this basically provides us with zero specificity words. We don't have to worry about specificity because we're not overriding any styles. We are just using existing class names provided by the framework. No naming collisions, because again, we don't write any more CSS, and no duplication of styles. So basically, all the all the biggest problems of CSS are basically solved through this small dogmatic approach of atomic CSS. But that's not all. I mean, we've covered so far 2 paradigms, and there is a third one that deserves its place into in this chronicle. This paradigm first appeared in 2014 and is currently known as CSS in JS. Now, we won't cover a particular implementation of CSS in JS. There are so many libraries, more than 50 out there. Instead, we will look at CSS in JS as a paradigm. And it's important to recollect that styles encapsulation was not available at that time, right? Also, atomic CSS and atomic CSS frameworks existed but were unpopular and quite exotic in 2014. That's why there is a great overlap between what CSS in JS is trying to achieve and what the other paradigms are doing as well. Because in the end, they all try to solve the same problems of scalable CSS. That's why the main goals of CSS in JS is to generate unique CSS class names, like CSS modules, and basically provide their own scoping mechanism. Also to support contextual styles, like CSS processors do with nesting and parent selector. Also to provide dead code elimination and to avoid bundling unused styles, which is also pretty difficult to perform without with semantic CSS, for instance. And also the ability to easily share variables between CSS code and JavaScript code, as we need to recollect that in 2014, CSS variables, the standard specification wasn't fully implemented that. Now, CSS in JS basically is just a tool. It contains a build step, and some library authors took this paradigm to a whole new level and basically combined its features with the other paradigms. And this resulted in really interesting synergies. In 2016, the first library to support atomic CSS in JS was released, basically generating atomic classes at build time instead of I don't know, a bunch of semantic classes. And the next year, the first library to support static CSS extraction was released. Instead of bundling the styles in JavaScript files and inject them into the DOM at runtime, these libraries were able to extract all the styles from JavaScript files and generate a plain CSS style sheet in the end that we can use like any other semantic CSS. So we could get the best of both worlds with this approach. We get the development experience of CSS in JS, and we get all the benefits of traditional style sheets, like the caching mechanism and all that stuff. So this looked like a pretty flexible solution, right, with CSS in JS, because we get the best of any of the paradigms. The only big question is what library should we choose? I remind you, there are more than 50 of them. I have personally analyzed more than 20 of these libraries in order to figure out the answer to this question myself. You can check out my thorough, if you have a similar dilemma, you can check out my thorough analysis of CSS in JS, which you can find on my GitHub profile at github.com/Andrei Pfeiffer/CSS in JS. It might help you as well as it helped me. Now, we need to take a break and see where we have been, what we have covered so far. Basically, in the end, we have 3 options to approach scalable CSS. There is the traditional way, the semantic CSS approach, right? When we use semantic classes, semantic names, we will probably use the CSS processor to support contextual styles and some kind of styles encapsulation in order not to rely on the global namespace and to avoid specificity wars. Another approach would be to learn an atomic CSS framework, or to build our own, if that's the case. The fundamental principles of atomic CSS basically solve pretty much all the problems of scalable CSS because of the single rule class definitions that they use. Or we can move our styles in JavaScript files and basically adopt or build a CSS library to do that. Additionally, CSS in JS, as it comes with styles encapsulation and contextual styles out of the box, we don't need additional tools in order to perform that. Additionally, we can opt in to generate the styles as atomic classes, atomic styles, or to extract the styles as static style sheets and that are easily cached by browsers. And there are libraries that even do both. They generate static style sheets with atomic classes. This is mind-blowing. This is what Facebook is doing lately, basically. But before we conclude this chronicle, there is one more chapter we need to cover. This is another added benefit to CSS in JS, and this is about type safety, type-safe CSS. Now, according to Wikipedia, type safety is the extent to which a programming language discourages or prevents type errors. Standard web technologies typically lack any kind of type safety, and I'm referring here to HTML, CSS, and JavaScript, right? We can use, for instance, any incorrect and non-existing class name in our HTML file, HTML code. Nobody will warn us about this, right? The browsers will simply ignore these classes at all. The same applies to CSS variables. You can use any misspelled variables or inexisting ones. The browser will fail silently without warning us. Now, this is not a huge problem during development, but it can become it becomes a nightmare during long-term maintenance and refactoring. This is where basic static type checkers enter the scene. That's why we have them, like TypeScript and Flow, because and these are non-standard tools for detecting compile time errors. And the power of type checkers is that they are able to detect errors before even executing the code, right? Any misspelled identifier or any non-existing property will instantly be highlighted by the type system. Now, if we add static type checkers on top of CSS in JS, then it's virtually impossible to use any non-existing styles or any misspelled identifiers. In the end, everything with CSS in JS and with static type checkers, everything is just JavaScript, plain JavaScript structures, identifier, constants, objects. So any misspelled identifier will be instantly detected by the type system. Now, with type system, we can go even further. It opens like new doors, new possibilities that we can do. One of them is to define typed interfaces for our components, which are really, really useful when we have to implement component variations, for instance, or design systems. we can restrict the input of the components to specific values instead of applying various, I don't know, if checks in the code. And this is beneficial to everyone. As generally speaking, types are self-documented, anybody reading the code will have an easy time understanding what it does and what it's supposed to do. Not to mention that any consumer of these components with these well-typed interfaces cannot pass any invalid values, right? And they will get instant type errors in their editor or in their console. And not to mention that they will also benefit of code completion and IntelliSense regarding which values are accepted as valid. But probably what I consider the most important thing is that type safety enables safe refactoring. And this is an essential practice during long-term maintenance because it eliminates the fear of changing existing code. Probably you have witnessed at least once that you are afraid to touch an existing code, which don't know exactly how it works, and you leave it there, right? Because nobody should touch it. If it works, sort of, let's keep it there. So with type safety, basically, you don't have that fear anymore because you have the type system watching your back and highlighting any potential errors that could surface. And they also provide tools, automatic tools, to perform day-to-day refactorings, such as rename, extract component, or extract something, move one part of code from one place to another. So it's really, really helpful. And lately, we've seen some significant efforts into introducing type safety at the platform level as a standard. For instance, in 2018, the CSS typed object model was introduced, basically providing a set of typed APIs to manipulate the styles within a browser instead of the old untyped APIs. And this year, we have a new proposal, ECMAScript type annotations, to introduce optional types to the ECMAScript language, basically providing type safety and type checking without the need of a transpiler. So slowly but surely, as far as I see it, the whole ecosystem is slowly moving towards a type-safe future. This was an overview of the evolution of scalable CSS. As I mentioned, I didn't dive into any of the specific of this topic because it's so huge, so vast. You can read the full chronicle on my website, andreipfeiffer.dev/blog. I will be here throughout the conference, so if you want to dive deeper into any of the topics presented here, or if you simply want to talk about scalable CSS or any other type of CSS or any other type of stuff or topics, I will be more than happy to talk to you. Just come over, pull my sleeve, and I will be super happy to talk to you. That being said, I would like to thank you for listening. Do enjoy the rest of the conference. Great talks are coming right up. And last but not least, peace to all of us.